2019 is said to be the warmest year on record. In fact, the last 4 years have been the hottest ever recorded, and the top 20 hottest years have all been within the last 22. You may be thinking to yourself, but it's cold out today, or this winter is freezing. You're definitely not alone. But this reasoning is incorrect. Global warming is the general trend of rising world temperatures, the key word being general. Day-to-day fluctuations in temperature is not an indicator of global warming. An actual indicator of global warming is ocean heat content, or OHC. When greenhouse gases get trapped in our atmosphere, some of those emissions are converted into surface temperature, but 90% of GHG is trapped in our oceans. Since OHC was first recorded in 1940, 2018 had the highest OHC to date. Another indicator of climate change is paleoclimate research, which includes the study of tree rings, ocean sediments, coral reefs, and layers of sedimentary rocks. The correlation between GHG and climate changes have been shown through the study of ice cores from Greenland and Antarctica. One of the biggest and most well-known contributors to global warming is the greenhouse effect. Earth's atmosphere acts as a greenhouse, trapping about 90% of the sun's rays and converting them into heat. Water vapor, carbon dioxide, methane, and nitrous oxide are the main gases in the air that do this. While the greenhouse effect is a naturally occurring phenomenon, human activity has increased the abundance of these gases in the atmosphere. The increases in deforestation, the burning of fossil fuels, landfill decomposition, and agriculture all lead to the worsening of the greenhouse effect. CO2 levels have increased by more than a third since the start of the 19th century. Over the last 150 years, carbon emissions have increased from 280 parts per million to 400 parts per million due to industrial activities. And maybe you're thinking, what if the sun is just giving off more energy? This has actually been proven irrelevant. Spikes and dips in solar activity have caused some climate changes in the distant past, but since 1750, solar activity has stayed pretty much the same, while the global temperature has continued to rise. 97% of climate scientists believe that increased human activity like the burning of fossil fuels has a direct correlation to global warming. The effects of climate change have already proven to be heavily damaging to the world. Natural disasters, the melting polar ice caps, and ocean acidification are all consequences of a warming planet. There have been severe droughts in Africa, South America, and Southeast Asia. Heat waves have also become more common, and in the U.S., they are projected to occur every 2 to 3 years instead of the typical 20. The number of natural disasters, like hurricanes and tropical storms, have increased over the years and are projected to increase in the coming years. The long-term average of tropical cyclones for the world is 53 per year, but in 2018 there were over 70. Storms have become more intense as well. Since 1880, the sea level has risen about 8 inches, and levels are projected to rise by 1 to 4 feet by 2100. The Arctic is expected to be ice-free by 2050 as temperatures continue to rise. Some people think fixing climate change isn't worth it. They believe that in order to fix the effects of climate change, governments will have to spend huge amounts of money. But climate change is costing us big right now. With the increased frequency and intensity of natural disasters, nations have been spending more and more in disaster relief. The damage Superstorm Sandy did in New York alone was about $35 million. Insurance companies are concerned about natural disasters as well. Premiums are starting to rise as companies find that they are unable to cover the costs of storm damage. Health risks will also rise as diseases move into areas where they weren't before, and heat waves become more severe, costing us more money in healthcare. Freshwater sources will decline as glaciers melt and snowfall decreases, net expenses for air conditioning will rise, tourism will be affected, and infrastructure will cost more to maintain. Overall, the percentage of the economy affected by temperature change is modeled by this graph, which was created by William Nordhaus and is in line with the IPCC's predictions. 2 to 5% of the global economy will be affected with a 4 degrees Celsius change in temperature. And this graph is exponential. As the temperature rises, damages to the economy will be more and more severe. The proposed solution to climate change is mitigation. The United Nations Intergovernmental Panel for Climate Change, the IPCC, created a summary on mitigation and how policymakers can implement it. Mitigation is a human intervention to reduce the sources or enhance the sinks of greenhouse gases. CO2 capture and storage technologies are a new development and could potentially replace coal-powered plants in the future. For now, the IPCC is encouraging the replacement of coal-powered plants with more modern natural gas plants. There's also the idea of carbon emissions trading, which would allow for a more cost-efficient way to reduce emissions. Companies with a low CO2 output could trade with companies with a high output. This strategy makes companies take things like natural and human resources into account, not just goods and production. Climate change and global warming is scary, but it's not a hopeless fight. First, we need to fully address the problem, because some people still say either it doesn't exist or doesn't matter. Then we need to come together and agree on a solution to lower GHG and carbon emissions. It's not too late.
Most of our atmosphere is made up of gas molecules that don't have an electric charge. They all have a balanced number of positive protons and negative electrons. But some molecules hold most of their negatively charged electrons closer to one side, lending them a lopsidedness that can jiggle back and forth to absorb the energy of incoming infrared rays. For example, water, ozone, and nitrous oxide are all electrically lopsided, so they all absorb infrared radiation. Then there are gases like carbon dioxide and methane. On paper, neither molecule looks lopsided, so it doesn't seem like they should be able to absorb any radiating heat. But in reality, gas molecules aren't motionless. They crash into each other billions of times per second, knocking each other in different directions and also into different modes of rotation and vibration. And it turns out that both carbon dioxide and methane spend most of their time shaking it in electrically lopsided ways, allowing them to absorb infrared rays and help insulate the Earth. Even though many different kinds of molecules can absorb infrared radiation, the vast majority of our atmosphere can't, because it's made of nitrogen and oxygen, which don't get lopsided even when they are vibrating. They're too symmetric. Nevertheless, the lopsided 1% are such good infrared absorbers that they manage to intercept about 90% of Earth's outgoing heat. Each captured ray gets pinged around the atmosphere, and most end up returning to the surface at least once before escaping to space. We don't need to visit the moon during frigid lunar night to know just how important the game of radiation pinball is for Earth. Ice records from our own coldest climate show that small natural variations in atmospheric carbon dioxide produce relatively big changes in temperature. They also show that, compared to the last 800,000 years, the game today is much, much harder.